Hello everybody, I'm Ian McCrum, Mike India 5 Alpha Foxtrot Lima. I'm going to talk to you tonight about my SDR radio receiver and talk to you a wee bit about the software that comes with it, which is more important than radio. The actual SDR 1a is a tiny wee grey plastic box. Well, not that tiny I suppose, but it has a USB-B lead in one end, connects to your computer, USB socket, and an SMA on the other, which connects to the aerial. The plastic box is conductive paint lined, and it only costs £94 plus postage. So I think it's a really good price point. Let me take you through some of the bits and pieces to do with SDR radio, and make yourself a wee bit smaller. What I'll talk about is a bit of a review of the technology, some of the SDRPlay products. Look at the SDR Uno, just as a simple receiver, some of the things about it that make it very useful. Good memory channels, plugins, how you link it to other software. Two important concepts, virtual audio cables and virtual comm ports are needed for that, and I'll talk a wee bit about that, which will help you get started. And then a wee bit, of course, about controlling transceivers, which you, as a ham, will want to do. And there's some subtleties to do with that. It's very, very important that you have a good transmit-receive switch that can cope with an SDR. So if you want to use one as a PAN adapter or as part of your logging or contesting, then CW skimmer, whatever you want to use it for, you do need to be really careful that you don't break it. And as well as using the RSP1a as a radio, it's a really useful piece of test equipment because its input levels, sensitivity of the signals are measured actually quite accurately in terms of dBm. So what is an SDR radio? It inevitably means converting the radio signal into a digital form. And although you don't need to know anything about the maths of this, but it's more convenient to convert it into two digital signals, what's called the I and the Q representation of the data. The two together make up the data. The data is split into two signals, which are technically they're 90 degrees apart in phase. They're quadrature signals, but all you need to know is that you take the radio signal, turn it into two streams of digital data, known as the I and the Q. They become the left and right channels of a stereo sound card if you're using a sound card. And the software copes with those two. So the issues that we have are how accurate do you convert the signals into numbers and how fast you do it. The other issue is how good your filtering is and how good you are to sort of coping with overload and things like that. But how accurate the signals and how fast, let's talk about that for a minute. So we convert to a digital number by a thing called an analog to digital converter, an ADC, and that will represent each incoming voltage at an instant in time by a certain number of bits, primary bits. Don't need to know binary for this, but if you sat and wrote down all of the possible 8-bit numbers that you could get together with ones and zeros, it would be 256 of them. So there's 256 unique numbers possible with an 8-bit ADC. And 1 part 256 gives you, well, is it obvious? Maybe gives you an accuracy of 0.4%. If you use 12 bits, you have 4,096 different values. 0.02%, it's obviously better. And my RSP1a is 14 bits, which is 16,384, which is obviously very accurate. And it's hard to get, you can get fast 8 bits and slow 14-bit, 16-bit. In fact, if you went all the way down to audio, you can get very slow, well, you can get audio 24-bit ADCs that are incredibly good at doing audio. So you can get, it looks like you can get a large number of bits or very fast, but it's hard to get both. So the very early SDRs we had, the very first ones probably to come out, I have a kit, I think, for a soft rock, which I must build sometime. But it was only half the story. It was a board that took the radio and converted it down to audio, and then used some quite good sound cards that were about in PCs. So you can get a good sound card that does 16-bit. Actually, you can get ones that do 24-bit now, up to about 192 kilohertz. You can also get bad sound cards that only do 8 bits at 44 kilohertz. That'd be really old now. And some of them are not particularly good, below 300 hertz and things. So if you are going to go down this road, either buy a good external sound card to your PC, or buy a good PC that has a good sound card in it. Anyway, you can fit a chunk of any radio, part of the radio spectrum, as long as it's only 192 kilohertz wide, or 44 kilohertz wide, or 96 kilohertz wide, or whatever you've got room for. And the soft rocks that come out, you can still buy kits. There's quite a number of them. Some of them, pardon me, are transceivers now, and the range from $20 up to $135. And after that, then companies made these little dongles that just plug into, if you see the size of the USB connector, it just plugs into a laptop or a PC, and received analog television when we had such things. Good at doing that, but it so happened that the particular chip that I think they all tended to use at the beginning, could actually receive any radio signal, and quite a broad band of radio signals, fairly easily from 25 meg up to 2 gig. And that was fantastic for anybody wanting to listen to anything between 25 meg and 2 gig. And the good news is they're only $10, but they were only 8-bit. And the limit at 25 meg was a bit of a nuisance. Now, some sold ones that had little converters built in. Okay. I have one here. I had an old one that looks quite fancy, but actually when you open it up, it's got one of these dongles inside it, and a down converter and some filters. They did actually manage to get a software way of dropping the 25 meg down to include the ham bands, but it's very prone to overload and needed good filters. But for $20, tinkering with 8 bits, it was fine. The website for this is rtl-sdr.com for SDRs in general, and it covers really all of them. And they actually list, and counted them, there's over 50 different SDRs listed in that site that have a review and how good they are. So if you move on beyond the basic RTL dongles, you get things like the products from AirSpy or FunCube. And AirSpy make a couple of products. In fact, they're about to bring out a third product, which will be very exciting. But basic AirSpy covers the same 24 meg up to 1.75 gig, but it is a 12-bit device, and it does give you 6 meg of bandwidth. Some of the earlier RTLs struggle a bit at that. The FunCube Pro was created for a particular reason, to support schools listening to satellite digital data, but they have been expanded out. Sorry. They've been expanded out, and the FunCube Pro Plus now gives 192 kilohertz of bandwidth, not that much, but it is a 10-bit device, so it is better than the original 8 bits. List some of the others here. Move me out of the way a wee bit. The top left, I put a Lime SDR in. I think maybe Richard's one. Actually, a superb product, $300, but it's a 12 bits. It's a 64 megahertz bandwidth. That's the most that I've seen, so that's really impressive. And it goes up to nearly 4 gig. AirSpy are going to bring out an improved version, HF Plus, And as you see there, it'll be a 16-bit device. Maybe with a bit of software trickery, it'll pretend to be an 18-bit device. Not a massive bandwidth, but still going to be a very useful device. And then there's 4 others which are fairly expensive. Flex radio, all of the Flex radio devices are SDR based. There's an element, and the KX3 and 7300, there's an element of down conversion for these. And although the 7300 down converts to 36 kilohertz, the panoramic display can take a couple of chunks of 36 kilohertz, I guess, and I think can produce a 1 megahertz spectrum. Somebody can correct me in the chat if I'm wrong about that, but I think so. And that brings me to the SDRPlay company, and they I've listed their 3 current products here. They had 3 previous products, so these are the improved versions. And over the RSP1a in its plastic box, 14-bit to 10 megahertz, which I think is a sweet spot. This for me anyway. And at 94 quid, it's a sweet spot in price. You can get the Duo, manifestly appears to be just like 2 1As, albeit in a metal box. It does give you a third option for the antenna of high impedance. And actually it's a little bit more than 2 because the 2 are so tightly locked together. It does allow some experiments where 2 receivers are very, very useful. You can put 2 antennas in that and do diversity reception. You can enhance your wanted signals and reduce your unwanted signals. You can do noise reduction, and there's lots of good reasons why diversity reception, quite advanced technique, but it can give you the edge in terms of good receivers. And the latest one is the RSP-DX. It's two tuners again, so in that sense it's like the Duo. It's actually, I think, probably better than the Duo in that it has very much enhanced performance below 2 megahertz. I think SDRPlay as a company occasionally get big customers in who order large numbers of products for particular, very, very particular specialized applications that these gadgets get applied to. So you can track down interference and do all sorts of things. Perhaps they needed good performance below 2 megahertz. You can, of course, build your own. You can do that on a breadboard, and I'm particularly fond of the YouTube videos from Charlie Morris, and he's built a complete SDR transceiver. He's built several transceivers actually, but this one is interesting because it has a teensy microcontroller in it, just like our own Gareth McLean used and wrote up on Contact. So the teensy has an audio codec, an audio little baby sound card, and I've just bought a teensy 4 at about 20 quid, and the audio codec at about 14 quid. And if you add in a couple of, well, this particular one here, he's used 2 mixers, 2 diode ring mixers, SBL ones. He's used 2 audio transformers here to isolate the microprocessor digital signals from the low level audio here. Anyway, 2 mixers, 1 low pass filter, and 1 single transistor preamp, and he got a transceiver together. He built a second version which used NE602s, a pair of NE602s as the 2 mixers, and I just used relays and filters and things around them. So dirt cheap, dead easy, 40 quid, job done. And I love the way it's done on an actual breadboard. Now the other one that's noteworthy perhaps is I'll talk about sort of 2 options here. You probably know about, you may know about the QCX from Hans Summers from QRP Labs, qrp-labs.com, which is Morse only. He was working on a SSB version, but he hasn't had time. He's too busy actually making QSX pluses and QCX minis and things. So the community has really started to develop this micro SDX. The original version was butchered board. You get a PCB from the QRP lab and you butcher it to make the SSB version. But it uses a very, very clever circuitry. It uses a Talo mixer, a switch, single chip, single op amp, maybe it's 2 op amps, and it uses a simple Arduino chip, the 18328, and a lot of lovely bits of circuitry, tiny wee thing, and again it's 45 quid. It uses envelope restoration, a type of envelope restoration to do or pulse width modulation to do the SSB. And if it's not, it's quite good fun. They're still developing it. It is quite easy to get bad sounding SSB out of it, but fascinating gadget. Anyway, back to the SDRPlay. So it's an up and coming field in many ways, but certainly the SDRPlay website does give us really good product for 94 quid. And it's only a box, so it has to be backed up by good software. Now, for years, there's been SDR console and a couple of others. I don't say SDR Sharp there, which I think I used 10 years ago, but there are a small number of packages, software packages that will do SDR receivers. SDR Uno is the one that SDRPlay give you away free. And it's certainly very powerful. As well, on the SDRPlay website, there's a spectrum analyzer bit of software, which is superb. Very quick look at that at the end of the talk. And their community links are really good. There's this vibrant YouTube, two channels actually. One is ham specific, and the other is specific to lots of other shortwave listeners and things. Satellite watchers and things that use the SDRs for different things. So the SDR ham guides in there are really, really good. So what I'll do now, I'll give you a quick demo of the okay, so starting up the SDR Uno software will initially bring up a single window. Reasonably complicated package. It's actually got 5 or 6 windows that you need to master, so I'll build them up one at a time. So the main SDR Uno window comes up, and we see that there's some buttons here that will launch other windows. Recording panel will bring up a recorder that will record the entire spectrum. I think it's the entire spectrum that you're receiving. It might even be the entire sort of 10 meg spectrum. I know it saves stuff at about 10 million samples a second, so it uses up to like 5 gigabytes an hour, but you can record the entire spectrum in the morning, come back in the evening, and then pick whatever station then you want to listen to that's in the morning spectrum. So the record panel is quite powerful in that sense. Scanner I haven't used very much, which brings us to these lower 3, and hitting RX brings up the receive panel, or the VRX virtual receiver panel. This is a bit just like your transceiver front panel. It's numbered here because you can actually start up 2 of these, and you can listen to 2 bands at once, but there are restrictions. Your maximum bandwidth is about 10 megahertz, so you could listen to 7 megahertz and 14 megahertz at the same time, or have 2 receivers set up for it. But they have to, the 2 receivers have to be within 10 megahertz of each other. Okay, so that's the basic receiver. It's got the usual things: mode, filters, couple of VFOs. I tend to only use VFOA menu. And you can either enter the frequency directly, or you can pick the bands. So I'll come to that in a minute. The other buttons up here, SP1 opens a full spectrum window. Let me bring that down. There is an SP2, which brings up a secondary spectrum, auxiliary spectrum, which is the output of the demodulator. So it's an audio bandwidth, and you can see the complete signal. I don't tend to use it very much. That's mainly it. There's one other button here called the memory panel, and then there's on the top line, I think probably every window has a button to launch the settings appropriate to that mode, and so this one here will certainly be looking at. It's slightly quickly done. You have to scroll a little bit to pick up exactly what you want to do, and we'll use that for, one is to set up a virtual audio cable to link the output of this to the input of another program. The other is to set up cat control, where another program can control the radio. There's another button here called OmniRig, and you use that to control your own physical rig. So this radio can control the physical rig, and then you can also have with OmniRig, and then you can have cat control, where another program, be your logging program or whatever, can control. It controls SDR-UNO, and SDR-UNO passes the commands through to the rig. You mustn't try and have the SDR control the physical rig and another program control the physical rig. So there are some restrictions when you have three things to set up. So you'll use that for the output. At the minute it's set the output to the speakers. I'll be changing that the output to a thing called a virtual cable at some stage. And under the cat, COM3 doesn't physically exist. There's a virtual COM port where COM3 and COM4, another virtual port, are virtually linked, and anything going out to COM3 comes in COM4 and vice versa. We'll talk about that later. So that's the settings button on the receiver and the VRX window. There is, you can set it up, it is set up to limit the switch to band. So if I hit play, I'll mute this for a minute, hit play, you'll see signals appear here, and we can pick up not just ham signals, but the shortwave listening is very good. Hi, I've just, at a later date, later on in the evening, conditions aren't very good, so I'll just show you a couple of things being received. I'll unmute. Hopefully, let me see what we got. Of course, when you click on them, they go away. Let's see what happened. Change the steps by right clicking in there. Oh, he's back again. Well, I don't think there's a lot of point in sitting looking at sitting and listening to me listening to stations. So you get the waterfall. You click. You can tune by clicking in the waterfall. You can sorry, I've actually zoomed way out here. You can change these digits with your mouse wheel, and you can change the digits again here, and you can do keyboard input, the orange keys. If I take off the space bar, and put the balance back. The other thing you can do from within SDR is the plugins window, and as this is building very quick because it's fairly new, Fran will read a spreadsheet of stations and frequencies and annotate the spectrum display, same sort of way that the DX cluster plugin will do, which I've actually enabled. Audio recorder
records what the radio is tuned to. You remember the record panel up there records all of the IQ. So I've enabled the DX cluster, which brings up this window, and I've logged on to the GB7 BAA DX spider in England. A bit slow to build up, but slowly the DX spots will build up. I don't know much about clusters, so I'm sure there's people that know better than me. There's quite a few coming through, although actually there was about 8 or 10 of them there a minute ago that were sort of coming through on the CW side of the thing. I'll zoom into this CW anyway. You can slide that along to 7,000. Well, there, for instance, let's see. Let's get this. There's obviously ones there. No. Etc. etc. So there's a DX cluster plugin. I'm not demonstrating it very well tonight, and where's the plugins? The Fran one isn't great. I have used the Black Hat Systems one, but there's good YouTube videos in it, so I don't really need to waste your time showing you that. So that's some of the plugins, some of the things. The memory panel is superb. There's Mike, one of the hams who I think works for SDR, has put out many dozens of YouTube videos specific to amateurs using the SDR. So if you have a particular thing, Ham Radio Deluxe, N1MM Plus, multi PSK, FL Digi, whatever program you have, he's probably done a YouTube video telling you how to do it. He's also uploaded a whole collection of really handy memories, and these are just plain text files, so they're easy for people to add to it. He had the times, the sources of time on the shortwave, the Volmet stations, the aeronautical. I don't know if that was working. Barely audible. Let me unload the. Stop that and quit it. You have to hit unload. It's possible to crash your SDR with these plugins, but hopefully we'll get away with it. Right, where was it? So the memories, Volmet, time, etc. It's all there. I also have downloaded a second set of memories from the EIBI. If you do a search for the EIBI database, you can download. The first thing you can download is the CSV file. That's all shortwave stations, and I think it's updated every week or every month. And you can download that CSV database, bring it into your memories, and you have a fantastic set of things here. Now let me sort of demonstrate if we pick something that's probably working. That is all. Let's see. Radio China. One of the nice things you can do is if you right click there and say filter by the frequency you're tuned to, it will list only, well, God, there's not a lot of them, only those stations and schedules that work on that frequency. So you can see that on 7.245 megahertz, there's a China Radio China International, and well, CNR2 China the business station. There's a Radio France slot from 6 to 7 in the morning, and Japan come in, and Radio Tajik and Voice of Turkey, I think, is transmitted radio. So that was brilliant for shortwave listening. Really, I've never really used memories much until now. This is really nice, dead simple, and really handy to use. Okay, so I've shown you it receiving something, and showed you the memories and showed you the plugins, all good stuff. So hopefully that's of some interest to you. Hello, a person with a cut beard the day after all the other previous videos were taken. It's the morning and just the reception's a wee bit better, so I thought I'd show you 40 meters in better condition than the previous one. Also, I have loaded the DX cluster plugin, but there's only 12 spots showing at the minute. I haven't figured out how to filter the plugins and things like that, but anyway, here's a better looking 40 meter band. I'll just take the mute off. Lots of SSB signals, as you can see in the waterfall. Don't think I'm probably getting him. Anyway, I just wanted to do a very quick video. I'll zoom in on them. Not that much more going on, is there? I'll zoom in a bit. Pick up the Morse. Presumably he's down here somewhere. So the DX cluster is as good as the traffic that's on the cluster, I guess. Okay, I thought there would have been more Morse, but anyway. Better to change the CW. Not a big one. Anyway, that will sort of do for now. It was just a quick look at a busy SSB portion. So the SDR is basically as sensitive as my 706, and I haven't really noticed much difference between the two reception-wise. Okay, that's it for now. Okay, we've got SDR, the basic software-defined receiver, the receiver working, and it's generating its output to a loudspeaker out the sound card. What if we want to take that and feed it into another program like WSJT-x or a WeatherFact program or an RTTY program? Well, we could take the audio out of our SDR and feed it into the audio in of our sound card and tell the other package to pick it up. So you could do it with a physical cable if you have enough sound cards. But there's a better way, and that's to use a thing called a virtual audio cable, which does exactly like a piece of copper does. The good news is, the good news is it's not complicated. The other good news is that you don't have much choice. There's only two bits of software that can do this, or two different companies producing products that can do this. One charges money, and the other one is free, and then they ask for a donation if you find you're using it a lot, but there's no restrictions whatsoever. So I went for the free one. Now, having said that a virtual audio cable is very simple, and it is, I'm going to show you that now. The company that makes it has, well, first of all, you can only get one cable from it, which is actually enough for what we're doing with the SDR, what hams do with SDRs. If you want, you can get a pair of cables or a set of 3 pairs of cables. For those, you have to make a donation and then download it, whereas you can download the one-to-one single pair.
without any bother. So I'll tell you what, let me make myself nice and small, and I'll bring up a web browser, and we'll search for a virtual audio cable, and VB audio cable is the free one. I'll go to it now, and it has a couple of products, of which the virtual audio cable is the first one that comes up, and it's a dead simple thing to install. So when you install it, what you get is an input device called a VB audio virtual cable. So you just click that and download it, run it. Now, one of the things you have to do when you run it, and it tells you this, is that you have to right click and run it as administrator, but it'll tell you what to do, and that's literally it. You just click it. It then advises you to reboot your machine, which I did. I've since seen on YouTube that people haven't bothered, but once you install it, you can run your device manager. If you hit the Windows key and type in device, well, DEV, it'll find the device manager. It's a bit hard to find, Windows 10. And then under the sound and video controllers, you'll see an extra device. Now this machine has got, obviously it's got the SDRPlay installed. This machine happens to have 2 sound cards, but and there's also a microphone on the webcam, which I'm actually using at the moment. And then this other device comes up, a VB audio virtual cable. And that will actually provide an audio, a VB audio in and a VB audio out, as we'll see. Okay, so you download that and install it, reboot, and then we're ready to go. Before I leave this web page, I'd like to tell you a little bit about a couple of the other products that the company do. One of which is, I find, is superb. It's a bit more complicated than just the simple virtual audio cable, but it's worth experimenting with. The voice meter, this is a French company, and as I say, they ask for donations, but the voice meter is a mixing desk, and then the voice meter banana is a mixing desk with more inputs, and the voice meter potato is a mixing desk with even more inputs. Now, some of us have mixing desks, real mixing desks. I have one, which I've yet to wire up. But the interesting thing about the voice meter banana, which I've been using lately, I just click the button. It looks pretty well, it is pretty complicated, but if you can manage a mixing desk, you can do this. And the nice thing about the voice meter banana is you have 5 inputs and 5 outputs, plus the ability to record, plus the ability to send audio over the internet and some more advanced things. And there's a MIDI lurking in there as well. But anyway, at its basic, it's a mixing desk. Now, the nice thing about it is you have 3 physical hardware inputs and 2 virtual inputs. And then on the output side, you have 3 hardware outputs and 2 virtual outputs. So actually, this free download will actually give you 2 audio cables if you do end up needing them. Now, I needed them. Well, the other thing that this can do is that, and I think it might be possible to do this inside Windows 10, but I think it's a very fiddly thing, whereas this does exactly what it says, and it shows you flashing lights and things. But you can connect one of your inputs, for instance, the 2 outputs, one can drive the headphones, one can drive the speakers, and you have variables, your volume levels in each one. And you can take the headphones and put them through an equalizer. Now, with my bad hearing, I'm finding that if I tweak the equalizer and lift the treble and drop the bass, I can actually hear radios a lot better. So an equalizer built in is very good. There are software equalizers available for download from other sites, open source ones, and I did experiment with one of them, but one software tool will do both jobs. So anyway, very
nearly worth a program, nearly worth a presentation on its own. Like, fantastic product, brilliant. Back to the virtual audio cables then. Download it, install it, and then if I bring up some of the Windows settings for sound, always a difficulty figuring out where everything is in the sound. We'll see that there's an output device attached to this VB audio virtual cable called cable input, and there's an input device called cable output. So the output of the cable will feed into a software package. So you pick your input device on your software package as being the cable output, and then your output device goes to the input of the cable. So the SDR output goes to the input of the virtual cable, and the output of the virtual cable goes to the input of WSJT. And let's see how that works in practice. So I'll start up SDR, remember where I've put it. Ba-ding. And again, we start the receiver. We could start the spectrum display. Now, there's a number of every window, nearly, I'm sure, has got a settings window. It's the settings on this one VRX, this one receiver you've got. Remember, you can have more than one receiver sorry, you just add another VRX. I don't know where it's going. It didn't do it. Interesting. There's it there. So it's the settings of a particular receiver that you want to do. I'll just delete. We haven't done that. Okay, so this receiver has got a settings window. Quite a crude thing, but we see there's a number of tabs here. We can go. There's more than you have to scroll down to get that small. And on the so we want to take the output of our SDR and put it on the input of the BB cable. Okay, and that's that done. Leave that there. Now on WSJT, it takes a little bit longer to start up. Okay, under the file settings, under the audio, we want its input to come from the output of the virtual audio cable. Okay, and if I'm going to run out of windows here, aren't I? If I start the receiver, well, I'll tell you what I'll do. Actually, I'll open the memory panel, because on the Amateru radio tab it lists my FT. I'll show you a better way of doing this in a minute, but this is simpler to understand, I think. So if I tune the radio to 30 meters, remember the frequency, so 10.136 would appear to be the FT at for 30 meters. So that's this working, and if I hit play, and there's it going. And the audio output of this, I have mute on at the minute, okay, but the audio, when I take the mute off, the audio output of this will go into WSJT. Not to be able to see it, I suppose. Click it. So I'll take the mute off, and then we'll bring this back to the front, and I better tell it that we're on 10 meters. I don't think it matters, actually. Probably not. Anyway, and there's the audio from the SDR coming in. So the output of the SDR is piped into the WSJT. That's okay, and we can change the frequency. However, one of the things you can do, you can tell WSJT to control the frequency of the receiver by cat control. How are we going to do that? Okay, we're going to do that with another type of virtual
connection called a virtual comm port, and it will do for serial ports what virtual VB audio cable will do for sound cards. So again, if I bring up a web browser, and this time I will search for, well, over virtual comm ports, it'll probably find it. There is a couple to choose from, some of which you pay money for. There is one in SourceForge called comm0comm. I think actually I'm going to search for it. And to go for the sourceforge.net, and there's it there. You've got an application 1, goes through the virtual comm port to application 2, and perhaps it'll be comm3 and comm4, perhaps it'll be something else. Now again, on the device manager, this time if I go to the comm ports, I'll see that comm0comm, well first, sorry, download it and install it. Make sure you get it from SourceForge. And you've a choice actually. It installs a driver with CNC-A0 and CNC-B0, and A and B are linked. That's your COM port. The normal software, when you install it, it also links those to available COM port numbers. And in my particular case here, COM3 and COM4 have ended up allocated to the virtual serial port pair. If you have a physical COM3 or COM4 in your machine, you're going to end up with COM5 or COM6. But whatever they are, COM0comm, the two that are linked, that mention COM0comm, are connected together. So I can quit that, I'll quit the web page and go back here. Now, back to the receiver settings again, and this time we'll go to the cat and we'll find COM3. You choose 3 or 4 as long as you use a different one. There's a little button there for enable, but before we enable it, I'm going to actually come over here and go to File. This is WSJT-x. Go to File, Settings, and the window for it has a radio tab. We did the audio one for the VB audio cable. Radio tab, the rig, SDR Uno rig control can, the SDR radio can pretend to be a TS480. So if I hit Kenwood and scroll down to get a TS480, tell it. So WSJT is going to think it's controlling a TS480, and it's got to go use COM3 in SDR, so we'll go to COM4 here. I don't think it really matters what the baud rate is, in fact. And I hit OK, and this is ready to go. It hasn't been able to talk to the radio because I haven't hit the enable. I hit the enable, tell it to retry, and it seems happy enough. Now, why is this important? It's important because, well, it means that we can change the software from a number of places. So if I go to here and switch to 20 meters, look over here, SDR magically changed to 20 meters. So the WSJT.x can control the SDR. Now, see how I can put this somewhere where you can see both. If I go over here and click on the 40 meters, the SDR has changed to the 40 meter FT8. Oh, magic. The WSJT.x has changed to 40 meters as well. So we have linked the virtual audio cable. The output of the SDR went into the input of the cable, and then the output of the cable fed the input of WSJT.x. And with the COM0comm product, we created a linked COM3 and COM4, and the
cat control of WSJT can talk to the SDR, the SDR radio, as if it's a DS480. So that's a simple look at the second, how you link two programs together. It's not the only way. In the plugins of the main window up here, there are community plugins, and there's the Black Cat systems, for instance, allows us to link this SDR software with Black Cat software. That's the WeatherFax stuff they make, the DX stuff they make. What's the other stuff they make? They make 3 programs, and they can link them with a plugin. You don't need any audio cables or comm links or anything. In fact, the plugin is done using, well, it's network software. It's using a UDP port, but it's more typically within the one machine, but that works okay. So you can link using networks, and there's YouTube videos on how to do that. So I'll not cover the Black Cat Systems plugin. I'll look at some of the other plugins now. But anyway, we can now. Hello again. Let me review where we've got to, and then finish off with some other bits and pieces that are important. So let me just switch to a few more PowerPoints. I'm more comfortable with PowerPoints than live videos, than demoing software. So what have we done? We've looked at how we start SDR Uno, the layout of the programs, how the receiver works. We look at the spectrum and things. We've looked at the memories and some of the plugins. Plugins are fairly new and are going to become really important. So the plugins to annotate the screen with the names of software broadcast stations or call signs from the DX cluster are there, audio recorder, and a streaming, a way of doing streaming to link programs into the SDR. But we have looked at how virtual audio cables and virtual comm cables can be used to get the Uno and another program connected. And lots of other programs can use the virtual audio cables and the virtual comm ports. CW Skimmer, you would normally set the cable up maybe for 96 kilohertz or 192 kilohertz of spectrum, and there's a YouTube video on how to do that. The logger programs are available as well, but really at that stage you want to move into the transmitters. So, well, first of all, the plugins do allow streaming, but it sort of has to be set up for that. I actually prefer the hassle of the virtual audio cable and the comm port. I can understand what's happening then. But, you know, a couple of clicks and you can get some other programs working. So what we're really going to talk about then is, as well as connecting the SDR Uno to other software, you can connect to a physical rig, click in the spectrum, and the radio retunes. Panoramic adapter is normally called. There's a good YouTube video on how to set your machine up, and if my cat interface from 706 hadn't have disappeared, I would be able to show you that. Very important, the TR switch. If you put a milliwatt, certainly if you put 10 milliwatts into the SDR from your transmitter, you'll damage it. They say, in fact, not to put more than 1 milliwatt in. So you also need quite good isolation between your transmit circuitry and your receive circuitry. So that's what we've looked at, virtual audio cable and a virtual comm port. Aerial goes into the SDR, and then you've got your WSJT-x as you saw, but it'll work with FLDG and multi-PSK and some logging program and CW Skimmer. So that's all good stuff. We can also stream over the network, don't have to set up cables or anything. And at the minute, the Black Cat software is the only one that does that. They have SSTV, WeatherFax, and some DX stuff as well. What we really want to be able to do, well, in the first instance, let's see how we would connect a physical rig. And we would do that. We do not use the CAT interface. So if I go back in fact, let me go back to that one. That one? No, hang on. That one. The CAT interface allows the SDRPlay, the RSP1a, the radio, that radio, to be controlled from another program, and the CAT stuff is set up so that the SDRPlay looks like a TS480. When we come to talk to the HF rig, we do not use the CAT port. You can use it, but OmniRig using a real comm port is the way to do it. So you have the two things built in, and it's very important that that you use OmniRig. Here as well, we see that with the aerial going through a TR switch, an external transmit receive switch, so the incoming signal goes to the SDRPlay. It's really important that that gets grounded when your transceiver is transmitting. 1 milliwatt, certainly 10 milliwatts will damage things there. On the rig, you have a coax which brings both the transmitted signal out to the aerial. It'll also bring the received signal back. You can receive using either, I guess, but for some applications, you're better off using the rig. All SDRs have a slight latency. Now, it's only maybe 40 milliseconds in the RSP1a, but you are better. For Morse and QSK, rig and Morse, you may be better keying the rig directly. And certainly you need a push-to-talk signal coming from the rig. You can use carrier operated transmit receive. So the circuitry in here can respond when it starts to see transmissions coming up the coax from the rig, but push to talk is probably a little bit safer and easier to set up. How does the transmit receive work? Well, the simplest way of doing it is with preferably 2 relays, with one changing slightly before the other. So there is an aspect of sequencing that would make this a wee bit safer. And this isn't the complete circuit. You need the relays, 12 volts going to the relays maybe, and 1 or 2 transistors, a couple of resistors to take the push to talk and switch the relay to the appropriate transmitter receive. Depends on the polarity of your push to talk. So here, one set of relay contacts, the 2 sets of contacts are shown in the transmit position. So when you're transmitting the signal from the rig, in fact, this contact isn't important, but when you're transmitting, the signal comes from the rig straight to the aerial. Also comes down there through the contacts into the aerial. That doesn't matter as long as there's no leakage across to the SDR. And the second set of contacts here have taken the SDR and grounded it to ground here at the bottom. So that's it in the transmit position. In the receive position, it comes down the aerial and back to the rig, so the rig can still receive stuff. It comes down here and doesn't, it comes down here and gets connected through to the SDR, and in addition we lift this off the ground position. So conceptually that's all it is. It would be best, particularly if you want CWQSK, that you have a slightly more complicated system with sequencing the relays, and you can buy a box from MFJ. It's just lately been improved actually, specifically for SDRs. It's $120. The SDR goes there, the transceiver goes there, the aerial goes there, and the control wire brings in the push to talk. And this circuitry here, this little diode doubler and capacitor and resistor and things, will detect transmission, so you can actually do an RF sense and switch the relays that way. But whatever way it works, you need a good TR relay if you're going to set up a panoramic adapter. You might be lucky and your rig might make it easy for you. You may only want the panoramic adapter put into the IF out of your transceiver and things like that. The YouTube video on it's quite good. So what we then have is with the physical rig, as well as this OmniRig link where the SDR, the RSP1a, the SDR controls the rig, and the rig push to talk activates the TR. If you have another program, perhaps logging, and it wants to control the rig as well, perhaps, you do not connect the logging program direct to the rig.
you connect the logging program to the TS480, and it will pass signals and control frequencies and modes and things through the 480 cat link down the OmniRig to the actual rig, and all three will keep in step. That's quite important. That's well documented again in the YouTube videos. And if you're handling digital modes, you can have you can run your digital decoding and transmission from your logging program, bits of HRD or whatever it is, and again down the cat and to the OmniRig. I haven't done that yet, but we'll do shortly. Okay, that's me. But TR switches, once you're controlling your transmitter, be careful.